name is Lawrence Otieno Ouma. Admission number TED 127/18, and this is for trip 2. So trip 2, we have the SCADA, and then we have the area of specialization, the computer area and the area of specialization. To start with the computer area, tackling the SCADA. So SCADA is basically used in controlling and analyzing industrial processes. So we collect data about the industry and about the operation and about the processes of the industry. Then from the processes, we analyze the data. The data collected is analyzed, and the data is used to control that system. It helps in the manufacturing processes and general performance of that system. So SCADA is a way of controlling a system using data from within that system. So we have computers, and then we have a network of data. So from the network of data, we know, or we program the computer in such a way that it can perform the next operation that is needed of the production line. So in a way, the SCADA helps in connecting to the control relays. So when there is a need, when there is an alarm, the data acquired is used in delivering commands to control relays of the computer. So the SCADA system, it also helps in handling alarm, to activate alarm indicator, and generate email used in some systems, so that we have a way, at least there is a way of informing some other people of whatever is going on in the system. It generates emails, it can generate calls that can be used as a way of alerting. This is as a result of there is a change in the system and in the operation of the system with regards to the earlier programmed way that it should be operating, the way it should be operating, the way it should be functioning. It has been altered. So in that case, it generates an alarm, a way of making people know that there is a change and there is alteration in the way the system operates, and is widely used in like electrical networks in town, so that if at all there is a loss of power, or there is a problem in the wiring or the fixing of the electrical system of the entire town system, then from the supervision of the SCADA system, there will be an alarm indicating that a certain specific point of the town has a issue, or is altered, or is faulted by. So calling upon need of repair or change, or any necessary adjustments that are needed in the entire system. So in most cases, that can only also be used in water and oil companies, the oil networks and the water networks, to help show how water and oil are networked and how they are flowing to different destinations. So if at all there is a change, there is leakage, then there is a way that the system detects and sends an alarm to the control unit. So from the control unit, there will be a person operating the control unit can detect that there is an error and there is a need of change in the entire system. That's basically what SCADA system entails. Then in area of specialization, in automotive technology, where we check the diesel engines and the petrol engines. In this case, checking on the petrol and the diesel engines, here we have different types of engines for petrol and different types of engines for diesel. Like in petrol, we have in diesel, we have compression engines, where we compress air, and then diesel is sprayed in the compression chamber, which in turn is ignited, or due to compression and the increased pressure and temperature, it will explode, moving the piston to the bottom dead center. So in diesel engines, it is the fuel that is injected, and then we have fuel, we have air, compressed air is in the compression chamber, in the combustion chamber, compressed by the piston. But in petrol engines, we have a mixture of air fuel mixture. Air fuel mixture is allowed into the cylinder, then it is compressed up. So the mixture is compressed up, and that's why even in petrol engines, increased amount of the mixture into the cylinder can lead to engine knock, because there can be a certain extent to which the temperature increases up to a certain level that the engine cannot contain, or even the entire engine block cannot contain, hence can lead to faultiness in the entire system of the engine. But in diesel engines, we compress the air. It is the air we compress, then we inject fuel into the entire system. So you will see that the engine system, the diesel engine blocks are quite bigger, they're quite heavier than petrol engines, due to the differences in the operation and the different components of the engine. Because the diesel stroke is longer. The stroke is the distance between the top dead center and the bottom dead center. So the stroke in diesel engines, they are quite short. In diesel engines, they are longer, but in petrol engines, they are shorter. So in that case, higher torque can be generated in the diesel engines as compared to the petrol engines. And basically, high amount of speeds, the revolutions per minute, RPM, can be generated in the petrol engines due to the shorter stroke. So the engine can be moving at a faster rate because of the shorter strokes experienced and the faster combustion. But in the diesel engines, we have ignition lag, where fuel is injected, we have compressed air, but the ignition has not yet been started. And in some of the diesel engines, we also have the plugs, how are they called? The heater plugs. They heat up, they increase the temperature of the sprayed particle so as to induce combustion in the entire cylinder. So generally, diesel engines are more efficient in utilizing the fuel components, the diesel components, the diesel fuels, because only a certain amount of diesel is injected into the cylinder. But in petrol engines, a large amount of fuel mixed with air is allowed in the cylinder. So the consumption of petrol engines are quite higher than the consumption of the diesel engines. Hence, diesel engines can go longer distance with the same volume of fuel as compared to the petrol engines. The petrol engines, they consume a lot of petrol as compared to the diesel engines. When we move to the aluminum and iron, these are components that are used in manufacture of the engine blocks. So iron has been initially being used from the olden times and from the past times. Iron has been used widely in the manufacture of engine blocks. But towards the modern ages, they are allowing the use of aluminum alloys. Iron tends to have much weight. So when the engine blocks are produced of iron, they're made of iron or iron alloys, chances are high that there will be loss of energy, because the engine itself will be having a lot of weight to move around before the components, before whatever we need to transport, before the other constituents of the vehicle. But the aluminum ones tends to be lighter in weight and efficient in operation, because they're lighter in weight. Then the repair of aluminum engine blocks are also simpler as compared to the repair of the iron ones. When there is a crack on aluminum engine block, the repair is faster and is efficient because it just failed. But in aluminium, we need a continuous process and a bit longer process for the complete repair of the engine block. So, but in all aluminium and iron engine blocks are produced by melting the components, melting the metals. So when aluminium is melted, it tends to coat up fast and form oxides around it faster than iron. Faster than iron. This one can lead to cracks on the aluminium, but the repair is quite easier than the iron. Then the aluminium engines tend to be bigger because they are smaller in weight but can be easily broken and can be easily fractured. So to compensate on the ease in fracture, there has to be a given width. So they tend to be bigger and wider than the iron engine blocks because the iron engine blocks are stronger. Hence, even thin walls can be used. But in aluminum engine blocks, we still have to use iron sleeves in the manufacture to reinforce the strength of the engine block. So lastly, the aluminum engine block is quite bigger and is quite lighter in weight. So even though we might have a bigger aluminum block that are being used in modern days, but it's still lighter than a smaller iron engine block. So most of the vehicles, 50%, are adopting the use of aluminum engine blocks as compared to the aluminum engine blocks as compared to the iron engine blocks. Thank you.